So hello everyone, welcome to the new video. We are discussing today linear equations and expressions. This is a new topic. In the last video, we have discussed about polynomials. You have already covered the assignments. You have gone through the questions. I hope you have answered all the questions. So now we are going to start another new chapter, that is linear equation and expression. So what is linear expression? We have already discussed in polynomial section that the polynomials can be classified on the basis of degree, and linear expressions are those polynomials which have a degree of 1. Okay, so you have to just revisit the polynomial chapter to find out that particular portion where I have introduced the linear expressions. Now in this particular topic, we are going to know how we can solve linear equations, how we can get the value of the variables, right? So the method of solving the linear equations comes with the following steps. So we are going to start with linear equation solving in one variable, right? So these are the following steps in which we are going to solve linear equations in one variable. Okay, so here we are, the method of solving linear equations in one variable. So these are like the theoretical process. Okay, when I'll solve examples, you'll be able to see exactly the steps in which I'm solving. So you have to just kind of remember the steps and implement in your uh, own applications, right? So the first point is simplify both sides by removing the group symbols and collecting the like terms. So basically the first step is pretty simple. You have to simplify the sides, simplify each of the sides. Let's say if the sides are not complex, if they are already simplified, then you don't have to worry. If they are complex, let's say if it's a combination of different numbers, variables, and everything, so in that case you have to kind of simplify it to a particular form. Now this is step 1. Step 2, remove fractions or decimals by multiplying both sides with a suitable factor, which is LCM or a power of 10. See, basically this is one of those process which you can follow. There are a lot of processes actually to solve a linear equation. So in this particular process, what they are saying is that you have to make the denominators the same, which I actually also follow, right? You have to make the denominators same, and then when you make the denominators same, you can just remove the denominators. Okay, I'll give you an example where the fractions are involved, where we will make the denominators same and then we will just remove the denominators, right? So this is point number 2. Point number 3, isolate all the variable terms in one side and all the constants on the other side, collect the like terms. So we have to isolate all the variable terms, the ones which are containing the variables on one side, and all the constants are the numericals on the other side, right? Now if a variable is in combination means product with another numerical, you are not going to separate them. You are just going to separate the variable on one side. That means what? The variable attached with the coefficients also, they will be separated on one side, because the whole thing will be considered as a variable. This whole term will be a variable term. That particular term needs to be on one side, and constant means only numerical, no variable, only numerical has to be on the other side, right? So after that, the next thing is we have to collect the like terms. We have to see what are the like terms and we have to collect them together. And finally, make the coefficient of the variable as 1. So suppose after doing all the iterations, all the particular operations, let's say you get on one side 2x and on the other side you get 8, for example. Now your objective will be to make the coefficient of the variable, which is here 2, as 1. Now when do you make it? You have to simply take the 2 and put it on the other side. Now how you are going to do that? That I'll explain with the help of an example. So basically you have to ultimately isolate the variable only completely on one side and get the value of that particular variable. Solving means to get the value of the variable which is in the equation, right? So here we are going to learn how to solve linear equation in one variable. Now when it is more than one variable, then we will do another approach. We will learn about that approach also in future. Right now we are going to do examples of linear equations in one variable, right? So let us take an example and let us see how we can do this. Okay, so this is our first problem. Solve 3x plus 5 equals to 5x minus 11. So I've taken a very simple question so that I can give you the ABCDs of solving an equation, right? So first, what we are going to do. So as the step of the equation says, that once we have simplified both sides, now you can see it is already simplified, right? On the left side we have got a variable and a numerical or a constant. On the right side also we have got a variable and a constant. So we are directly going to that particular step where we have to take all the variables and isolate them on one side and take all the constants and isolate them on the other side. Now which one is a good strategy? Taking the 3x to the right or taking the 5x to the left? The good strategy is taking the 3x to the right. Why? Because there is a rule in equation solving and I'm giving it right here. So the rule is, let's say this is the equal to, right? This is the equal to. This is like a wall. So suppose if someone is positive on the left side and it has to be transferred on the right side, so he will change its, it will change its sign, right? It will change its sign. Suppose it is initially negative, goes to the other side, it will become positive. Now this is a two-way process. It's not just going from left to right, it can come back as well. It can come from right to left. Same condition, same kind of thing will happen. When it is going from left to right, sign change, right to left, again sign change. Someone is multiplication, now goes to the other side, it will form division. Someone is division, goes to the other side, it will form multiplication. So this is the criteria. When it is transferred from one side to the other side, the changes in the sign occur, right? So here also same thing will happen. Now think about it. Like if I take the 5x on the left side, the 5x will be negative. Why? Because on the right it was positive. Now, if the 5x becomes negative on the left, then I'll get a negative value on the left. Is that feasible? Or I take the 3x on the right and it will be 5x minus 3x for the same reason. And then I get 2x, which is a positive value. So I'm not saying that you shouldn't take it. I mean, you cannot take 5x on the left side. You can, definitely can. But it's always wise not to play with danger, right? And negative sign is a danger. So avoid that. So now, what we are going to do, we are going to bring the 3x on the other side and the negative 11 will come on the left. So when negative 11 comes on the left, since it is negative, it will be positive now. And we already have 5. Now we haven't written 3x over here. Why? Because 3x now has been transferred to the other side. So it is 5x minus 3x now. So now you can see I've written two changes in the single step. One change, 3x goes to the right side, becomes negative 3x. Second change, negative 11 comes to the left side, becomes positive 11. Now, here we are getting 16 and here we are getting 2x. So 2x is equals to 16. Now what is x? So again 2x means 2 multiplied by x. Now if I want x, I have to take the 2 on the other side. Since 2 is multiplied, if it goes to the other side, it will be divided. So it is going to be x equal to 16 divided by 2. The result is 8, right? So this is the way in which you have to solve the equation step by step, right? This is the way. So let us solve one more equation. This time I will tell you how to solve a fraction based equation. So one of the methods which I generally follow, I'll tell you that. And as I told, there are n number of ways you can solve a problem. So it's completely on your own wish how you want to solve it. So let us take this equation. I'm quickly writing it. 3x minus 1 over 4 is equals to 8. Okay. Now, first what we need to do is we can just bring all denominators. So 3x can be written as 3x over 1. I hope you know that. 1 over 4 and 8 over 1. Okay, when there is number or anything that doesn't have a denominator, automatically denominator is by default 1. Now, you have three denominators. My objective will be to make all the denominators exactly the same. So we have to take the LCM of denominators, and LCM of 1, 4 and 1 is just 4. So we have to make all of the denominators into 4. Now when we convert all the denominators into 4, now what are the changes? Now see, as per the rule, if I'm multiplying 4 here, I have to multiply 4 on the top. It is already 4, so nothing to do. Here also I'm multiplying 4, here also I'm multiplying 4. Okay, if you are not aware of the rules, I'll tell you to first of all visit all the rules related to this fractions and stuff. Okay, it is very difficult to explain every single basic math here because we are for SAT prep here. We are not into the basic math prep here. So I'll request you to go over those fraction rules and try to understand them. Okay, and in future if I get an opportunity, I'll try to make a whole course on the basic math also so that you can be benefited with it. So now coming to the next step. So we are getting 12x over 4 minus 1 over 4 equals to 32 over 4. Now all the denominators are same, so we will remove the denominators. 12x minus 1 equals to 32, right? 12x minus 1 is equals to 32. So final answer, it will be 12x equal to 32 plus 1, which is 33. Okay, 12x is equal to 32 plus 1, which is 33. Why? Because the 1 has gone to the other side, right? So the final answer now, we have to find the value of x. So the x will be equal to 33 over 12. Okay, the x will be 33 over 12. Now this is not the final answer because you can simplify this one. So 3 divided by 11 and 3 divided by 4, which is 11 over 4, which you can convert into mixed fraction. You can make it 2 and 3 over 4. So this will be the final answer. Even if you can keep it like this, that is also correct, but it totally depends on the question and the options if it's an MCQ, right? And if it's a grid-in, I will say you should take it as 11 over 4. That is how you can grade it on the grid-in. So this is how we solve equation. This is like the initial portion, like initial part of solving equations. On the next video, we are going to solve some critical equation, some complex equation in the same method. When I say critical, it doesn't mean that it's very difficult. It's just a little sophisticated. We have to break the knots, that's all, right? So we are going to do that on the next class, and until then, have a good day.